Okay, guys, thank you so much for joining to this live session. First of all, the reason that I'm wearing this headphone and this microphone is because we're gonna share all our interviews and as podcasts on podcast platforms like Spotify, Apple Podcasts, and Google Podcasts. So the voice quality is important, and you can always listen to our podcasts in these platforms without watching the videos. So this is the reason I'm wearing this headphone. We're super excited and super fired up about today's live session. We are really in a great company today. We have Jan Knippers, a structural engineer, a super genius structural engineer, joining our live session from Stuttgart and University of Stuttgart. I would like to go a little short introduction about Jan Knippers, and after that I will invite Mr. Jan to this live session. Jan Knippers is a practicing consulting engineer, founder of Jan Knippers Ingenieure, and since 2000 has been also head of the Institute for Building Structures and Structural Design, known as ITKE, at the University of Stuttgart. His interest is in innovative and resource-efficient structures created at the intersection of research and development and practice. I don't want to waste a lot of time for the introduction, because every second of this interview is really important, and I believe it's really valuable for all architects and designers who are watching. So I'm inviting Jan Knippers inside the live session. Hello.
Hi.
Hi, Jan. Hi. How are you?
Good. We have similar glasses, I can see.
Yes, we're both rounded glasses.
Okay, but I need a haircut. That's what I can also see. Yeah.
That's good. Mine is also like long hair as well. It's pandemic and we can't get out.
Okay, here I am.
Yeah, that's great. Thank you so much for joining to this live session. We're super excited about this discussion. Would you like to say hello to our audience?
Yes, hello to everyone. I don't know how many people are listening to us, but I'm really excited to be here and be invited by you, Hamid. Thank you very much for that.
Thank you so much. Thank you so much. Is it possible for you to make that microphone a little bit close to your mouth?
Okay. Is that better?
Way better. Yeah, way better.
Okay.
That's great.
Okay. So I keep it like this.
That's great. Yeah, almost 200 people watching us live, and we're live on the Instagram right now. Before going to my question and starting this discussion, I would like to say to our audience that you can just write your questions in the question box down below. I will be exploring them during the live session, and I will ask them from dear Mr. Jan. So if you have any questions, write them in the question box down below, because I'm closing the comments to increase the quality of the video. So turn off the comments. That's it. There we go. So dear Jan, thank you so much for accepting our interview request. First of all, I would like to ask, would you please talk a little bit about yourself and your story of becoming an engineer, and what happened you choose this profession?
So thank you very much for this question. I had an early interest in building things and creating physical objects. So I was building cottages with friends of mine in the backyard of my parents' house. I was building large landscapes or a model train in the basement of my parents' house. Mm-hmm. So I had an early interest in architecture and building things, creating physical objects. And when it came to choose a subject for study, I was somehow in between architecture and engineering. I did not really know what to do and what to decide for. But I had no, in my family, they were all doctors and lawyers. So there was no architects, no engineers. So I had no one to talk to and no one to give me any advice. And I was at that time pretty confident about my capabilities in math and in about my analytical skills. But I was not so sure about my artistic talent. So I chose to become an engineer. That was basically the story. Yeah. And I think I had some points of my career where I was not really sure if it was the right decision, but now at the end, I think it turns out that it was the right choice for me.
Yeah, that's brilliant. Which year you were in the university? 19, like.
I was in the 80s. I studied in Berlin, the Technische University,
Yeah.
and I did my diploma 3 weeks before the wall fell down.
Oh.
I was there at a very exciting time.
Yeah.
It was pretty great to live there, to study there. Yeah.
Impressive. Right.
But the university itself was at that time very conservative in Berlin. So we went through all the basics in maths and mechanics, and we went through all the building codes, but there was absolutely zero creativity in our studies, zero link to architecture, zero link to any kind of cultural, societal context. So when I completed my studies, I had, sorry for this.
No problem. It's
Small accident. I had to leave Berlin and had to look for another place to go. And that was at that time Stuttgart.
Yeah, great. So talking a little bit about your projects, for example, Expo Access Shanghai 2010 or Convention Center Kigali, Rwanda in 2016, or one of my favorites, which is Thematic Pavilion Expo Yoso in South Korea in 2012. You have built up a good reputation for highly sophisticated consulting services in some of the most demanding areas of facade design and structural engineering. How does it really work when you reach to a point that current technologies they don't have the capabilities of a certain project that you are facing, and instead of rejecting that project, you start to innovate and bring new ideas of engineering and construction into the market? How does it really work for you?
No, I would more put it the other way around. I try to seek or to search in each project for a kind of small point that is there that promotes innovation and that it allows for new approaches, new technologies. And I try to seek for this point and try to push it and to bring it to reality. That's how I do it. It's not working in all cases. So because it's not only depending on me, also need a kind of team constellation that allows for this. You also need to have partners from architecture and also clients who actively support new ideas and are willing to take risks. I mean, at the end, it's all about taking responsibilities. And I'm of course always willing to take responsibility for my part of the design job. But the others also have to take their share of responsibility, and this is sometimes very difficult to find. A team constellation that allows innovation, and in particular for the thematic pavilion in Yosu, that was a very lucky situation, because not only the architect Roma, Christina Schineger and Stefan Rutzinger, which are both now teaching in Innsbruck, but also the client, the owner of the building. They were all of us seeking for this new approach to kind of kinematic facade. And this is something that you find very rarely in practice.
Yeah, brilliant, exactly. Which one of your projects was the most challenging one in terms of dealing with the structural engineering of it? And how did you overcome this challenge?
I think this is, in terms of technical challenges, I would say that this Buga fiber pavilion that we built last year in Heilbronn, I think most of you might know it. This was probably the most challenging one, because we had to meet all building requirements. We had to receive approval by the authorities, and also the opening date was set, but the project is light years away from any building code or anything similar. So we had to follow typically totally new ways of designing and proving integrity of the system. Yeah. But this was on a more technical level, on a kind of personal experience. I think what I notice now as I get older, I think now I'm kind of now as I'm getting older, I'm more how to say this. I developed a kind of routine in handling this kind of difficult situations. What is also pretty surprising is that when you get older, suddenly people take your advice and listen to you. Yeah? When I say this is going to work and this will be finished in time, then surprisingly enough, people believe me. They trust in me. And this did not happen. This does not happen. This doesn't happen when you're a young engineer or a young architect.
When you were 30, this won't happen. When you were 30.
Yeah, genau. That's why I think in terms of personal experience, I would say the most challenging projects were the ones at the beginning of my career. When I was working at the Schleich office, I have a picture here. This was one of the key projects of my career. I try to show the whole. Can you see this bridge?
Which project is it? Ah, yeah, I remember.
This is a folding bridge in Kiel.
Yeah.
And I was a young engineer, 2 years of professional experience, 0 reference projects for this kind of cable bridges, and I was totally on my own. Had to go there every week for these meetings, and the pressure was enormous on the project because it had to be completed on a certain date for the opening of the ferry terminal there, and there was enormous pressure on me at that time. But because of the pressure, the satisfaction when it was built and finally functioning was so high, so that I was forever spoiled for any kind of routine project. And I'm constantly seeking for this kind of engineering adventures since then.
Yeah, brilliant. So, who were your biggest influences in engineering?
So for me, to be honest,
What was the? Are there any engineers before you become engineer that influenced you to study this profession?
I mean, these are 2 different questions, I would say. The first question in my personal career, I was actually sometimes, as I said earlier already, a pretty frustrated student of engineering. So I explained this already. I was not a very happy student of engineering. I was seeking for an environment where we had this more open-minded context. And I was finding this in Stuttgart, in the office of Jörg Schleich at that time. And actually, I have to say that he probably saved me for engineering, because suddenly we talked about the aesthetics of bridges, about solar energy, about the social relevance of construction works in India. So suddenly kind of whole world opened, and this somehow saved me for engineering. And I spent 5 or 6 years there, and this was a good start for my career. It took me a while then to understand that many of the ideas that Jörg Schleich developed for his cable bridges and for his large stadium roofs, that the ground for this idea was prepared very much by Frei Otto here in Stuttgart.
Yes.
So many of these ideas were from Frei Otto, and Jörg Schleich scaled them up to larger projects. And Frei Otto was more or less 10 years older than Jörg Schleich, so somehow one learned from the other.
Yeah. Actually, I would like to ask about Frei Otto as well. Would you please talk a little bit about the lightweight design and the Stuttgart tradition around the Frei Otto?
I think what is interesting is that but also Achim Menges and many others.
Yeah, because Frei Otto was one of the engineer architects that was inspired and also admired by many, almost all architects. And in 2015, he got the Pritzker Prize a couple of months before he passes away. Would you please talk a little bit about his influence on the subject?
I think that he was not only between architecture and engineering, he was also between natural science and architecture and engineering. We tried really to cross borders of the discipline, and he created a kind of interdisciplinary environment here in Stuttgart that is still alive until today, because he attracted many people like me but also Achim Menges to come here to Stuttgart and not to go to other places. Because what we have here, what is pretty special about Stuttgart, is that we have really collaborations across all disciplines, with aerospace engineers, with fabrication engineers, also with natural scientists. And this is something that I think you can find very rarely in other places. And this is something that goes back to Otto, who somehow set up this large research project, integrated many people, and looked across the boundaries of his own discipline.
Yeah. You're the head of the Institute for Building Structures and Structure Design, known as ITKE, and at the University of Stuttgart. And I know that ITKE has an interdisciplinary environment that pushes the boundaries of like design and architecture. How do you think that these studies, which we have seen in certain scales, will affect our future architecture?
Yeah, I think I somehow changed my strategy a bit, because as I said earlier, in practice, in the data, I found it pretty frustrating that it's so hard to achieve innovation in the daily practice of engineering or architecture. That's because, as I said earlier, you need this kind of team constellation that all together, the client, all the design partners have to be interested and push the boundaries. That's why what we do now is we try to explore new ideas, also in the scale of 1-to-1, in a kind of academic context, kind of protected academic context. And only once they reached a certain level where we proved that they work, we proved functionality, then we try to transfer them to practice. And we are right now at this point, actually. So we are now, we had this Buga pavilions last year. One of them was shown by you in your pics.
Yeah.
And we now reached that you shared. And now we reached the point where we can transfer these approaches to regular office buildings or multi-story buildings. That's where we're right now working on.
Yeah, actually, my next question is about these pavilions as well. We're seeing that in ITKE and in collaboration with ICDE, both University of Stuttgart, you are using a lot of manufacturing techniques such as robots, drones, 3D printing to build research pavilions like Buga Fiber Pavilion or Urbach Tower or Buga Wood Pavilion, and also a Lystra Filament Pavilion, which are built up on many years of biomimetic research in ITKE and ICDE. How far we are from the point that we should see these manufacturing techniques and tools in normal projects? Because using these tools are quite expensive, and we can't still use them in the normal manufacturing construction sites as well. How far we are to use these tools?
So a robot actually is not very expensive, to be honest. So a robot is quite cheap these days. What is expensive is to train the people.
Program it, right?
To program it and to steer the robot. That is expensive. Part of it. And but actually both Buga pavilions were built in collaboration with partners in industry. So we had this kind of mobile robotic platform that was installed in a kind of medium scale timber workshop, and it was used there to produce the things. And I think this is one of the main advantages of this robotic fabrication, that it is flexible and allows for on-site or in-shop fabrication. I think that's where I see the future also of this fiber winding technique. You can install the robots on-site, that you bring only fiber spools, resin cans on-site, and produce without any noise, without any dust or dirt or any kind of emissions, on-site large-scale components. That's where I see actually the future of it. And we are currently working on this.
Yeah. Are you trying to build something like in the future research projects, maybe an actual housing project, or like small scale architecture scale, like human living projects? Because most of these projects are pavilions or installations, and they're not livable.
Yes, that's a comment that is often made, in particular by architects, that what you are doing is not really architecture. And in a certain sense, that's
I haven't
also
read all those comments. That is just my question.
no, but that is a question that is often asked and a comment is often made. And I think we have to understand that we see this pavilions more as a kind of physical manifestation of the research that we are doing on fabrication and design processes.
Yes.
So we don't think that the pavilion itself is a kind of role model for the future of architecture, but
yes.
the underlying fabrication and design principles, they may be transferred to other applications. And we are currently working on a lab building, pretty large lab building here on the university campus, where we want to build the roof out of woven carbon fiber components. And we're also working on an office building here close to Stuttgart, where we use woven fiber components as a kind of facade cladding and shading device. So we're now at the stage of transferring these ideas to real architecture.
Real architecture. Also, are you thinking or working on something like for NASA or these kind of stuff to build on, like on
Mars?
Yeah, on Mars or on Moon, or the places that we can't reach, but robots can go there and they can build stuff before we go.
No, we're actually not doing this.
You don't have any program on it?
No.
Oh, okay.
No,
not at the moment, but you're interested, right?
But that is what I want to say, that the robot is not only for the Moon or the Mars, but for any kind of situations that are remote and difficult to reach, also in kind of existing buildings, for example, or also in other natural areas that are difficult to reach, because, as I said, you don't have to have a truck that transports large components from the shop to the site and drive through the dense city centers. You can produce on site, and that I think is the true potential of all this kind of robotics application facilities in the long run.
Yeah. Hopefully one day we will do it on Mars.
we will see it, yeah.
Yeah, we'll see it. Who are some of other engineers that you admire their works today? Like
today. Okay.
Not yesterday, yet today.
No, I think we have to, you as architects have to understand that this kind of community of creative, conceptual engineers is much smaller than the community of creative and conceptual architects. So there are very small clusters that you can see of engineers that really think beyond the kind of daily work.
Yes.
And I think we have this in Stuttgart, we have this also in London, but for example, the London engineering community is Hanif Kara and Chris Weiss and Neil Thomas. They have a completely different understanding of engineers than we have.
Exactly.
Than we have here in Stuttgart. So we try to promote engineering through science and to really push the technological boundaries. And I think Hanif Kara is a fantastic communicator, is a great communicator and speaker.
We have interviewed with him as well.
He's a fantastic guy, but he sees himself more as a kind of enabler of architecture. Has a different understanding of what engineering is than we have here in Stuttgart.
Yes, exactly. Also, you have researched a lot about the industrial developments of the building materials such as timber, glass, steel, or facade elements. And you had great achievements with innovative materials such as glass fiber reinforcement polymers. Would you please talk about the importance of pursuing the new innovative materials for our future?
No, I think we have to be aware that we are building our houses with a very, very limited set of materials. I mean, we're using steel, concrete, masonry bricks, and timber, the same materials that we used 100 or 200 years ago. And this is a very limited. That's a very limited range of materials. And there's so much more beyond that. And for example, in particular fiber composite materials, you can see them everywhere. I mean, we have the windmills in Germany everywhere. They're all built out of glass fiber and carbon fiber reinforced, reinforced polymers. We see the aircraft. Yeah, they're also using more and more, even for the very important parts of the body. They're using carbon fiber composites. So everywhere you find them, also in the car industry, except the building sector. And that's why we thought we had to do something with it. And I think the mistake that was made in earlier years was always that people tried to transfer fabrication and production techniques from other fields of industry to the building sector. Yeah, so we have this.
Like what?
I don't know. If, like, I mean, there's this constant narrative among architects like Buckminster Fuller or also Norman Foster that we just have to look at the aircraft industry or the yacht industry and see how great things they're doing, and we just have to look at their technologies and transfer them to architecture, and that will push us forward. But this is not true, because this is not true. It doesn't work, because the conditions or the requirements of these fields of industry are completely different from what we have in architecture. We have here large-scale components. We have unique items, different geometries. We don't have this top performance requirements of the aircraft industry. They're very different sets of requirements. That's why we had this idea that we cannot transfer fabrication techniques from other fields. We have to develop our own fabrication techniques that are adapted to our specific requirements. I think that is mainly the basic idea behind our pavilions, that we as architects and engineers have to develop our own application strategies. And then, of course, in the next step, we need, of course, experts to help us to program and to develop all these mechanical devices. But the concept itself for the fabrication process, that has to come from us, from ourselves.
Yes. Actually, I will ask that question a bit more in details in the design process. But before, like, architects were always away from the building part of the construction part of the building, and all those tools that were built for engineers, they were not exist in architecture profession, and architects were just exploring and bringing these tools in architecture. And I think in the past 30-40 years, this gap between architects and engineers has been reduced because of using these tools, like computational tools as well. I will discuss this later, but before going that, I want to keep this question to be more in detail. But before going to any other topics, what are some upcoming projects that you are working on them on ITKE or on your own practice, Jan Knippers Ingenieure?
So now, as I said, we have this larger project now on the table where we try to transfer these ideas of robotic winding and also of the robotically fabricated timber components to multi-story buildings, to lab buildings. I think that's what I have in mind, what also Otto and Achim had in mind, to use kind of science as a kind of protected field to develop ideas, to test ideas, but then not to stay at this level, but then to transfer it to the built architecture. I think that's our ambition. That's what we are working on trying to. And I think we will see. I think we will see some projects.
Yeah, great.
Pretty soon.
So, as you know, in the past 30-40 years, architects are using vastly using advanced computational and parametric tools like parametric design tools as well in their design projects and in entire projects. How does the use of these tools by architects facilitate your works as an engineer in understanding of the structures of the building? And actually, does it facilitate or not? And because I'm asking this question because it's based on understanding of the how to compute a design or how to compute a form. I don't want to call it a form. How to compute a geometry, because when you are using these tools, whatever you are doing with these parameters, relations, like all those curvatures, they are being calculated, analyzed, and they are not just thrown there like a sketch. And everything in the 3D environment of the 3D software is being calculated with computational tools. Does using of these tools by architects facilitates your work as an engineer? This is a really important question, I think, and the most important question that I have from you is this one.
Okay. No, I think from an engineering perspective, the most important invention was the introduction of computational analysis methods, of finite element methods that we have seen in 1980s, 1990s, were introduced in the regular daily practice of engineering. And since then, we are working on integrating this kind of tools, of kind of design tools, geometry modeling tools, and analysis tools. And we also have seen in recent years these new tools of Karamba, for example, or Kangaroo, who allow kind of integration of and structural analysis of an early design stages. Mm-hmm. So I think this is somehow solved to a certain stage. But what is missing actually? What is missing actually is the connection to the fabrication and construction of the project, because you see all kind of complex geometries, but from an engineering point of view, the structural systems behind them are pretty conventional and old. So maybe mostly truss girders in kind of weird forms, or hinged arches, or triangulated lattice shells. So these are all systems from the 19th century, actually, just in a more complex shape and geometry. And I think what we want to do is now we want to link them to fabrication, as for example, was robotic winding, to enable also new structural forms beyond this very limited set of typologies that we are using in our engineering basis. So from my perspective, you see a lot of very complex geometries, also aesthetically convincing geometries, but the underlying structural concept is very conventional and goes back to the 19th century, typically.
Yeah.
That's why we see this. Why we see it's very important to work to enable this link to fabrication and production. So we had this. I have this here on my desk. We did this. This is a 2008 year model of the two. A bit yellow already. Here for this one, we first developed the fabrication process without knowing how it would look, how the structure would look later, or how the structural system would work later. So we first worked on the fabrication process, developed this idea of robotic winding and fibers, and then we explored what we can do with it. And this somehow led to a completely new, also from a structural perspective, completely new structural system. This is not an arch, or this is not, I don't know what, a shell. This is something, I don't know what it is. Yeah, something beyond any kind of structural typologies of the 19th century.
Yeah,
I think this is what we have to.
Yeah, that's really interesting that you are measuring what the tools that the construction and manufacturing tools that you have, and analyzing them, calculating them, and just knowing that what you can build with them in today, and the design doesn't matter, and you just apply it in any kind of design. And that's really brilliant, actually, admirable.
Because this will not only lead you to new structural forms, but also to new architectural qualities. Haptics, visual expression is completely different and unusual. And this would never have happened if we sat on our table and tried to design a form and then think how to fabricate it. Just because we switched it the other way around, this enables kind of completely unusual architectural form and structural system. I think that's what we try to.
That's what makes it more interesting, actually. Architects are doing. Some architects are doing it reverse, just designing the form. What inspires you in daily life?
I think what is still, for me, a kind of constant source of inspiration is actually teaching, yeah, to be honest. Talking to students would come with some kind of totally weird ideas, and you are constantly forced to think outside of the box and to try to somehow transverse this weird idea to something that makes sense. Yeah. And I think this is a kind of constant source of inspiration because it constantly breaks routines also. Yeah?
Yes.
Leads you constantly to new ideas. So I think I enjoy the teaching that we're doing within our ITKE program very much. Yeah.
Yeah. So we have one question from one of our audience that I think somehow you answered this question, but if you want to go more into details, Stefan asks, your work always aims to use the resources that is owned efficiently with the existing technology. Do you think that we have achieved this efficiency in today's construction industry? If yes, and how can we manage to use the resources we have more efficiently?
Yeah, I think the structures, the building structures that we're using today, they are all optimized towards easy manufacturing, I would say. Not towards structural efficiency, but towards enable easy, fast, and cost-efficient installation and construction.
Yes.
So they're not, in that sense, they're not resource efficient. If you look at the kind of regular office building with kind of concrete slabs, there's so much of that material carried around, using a lot of, producing a lot of carbon dioxide emissions. And I think we have to look for completely different ways of, again, brings me back to the same point again.
Yes, again.
Completely different points of constructing these things. Yeah, because right now labor is expensive, material is cheap. So what we do is we make the things, design the things in a way that they require as less labor as possible. Yes. And this is something that needs to be changed.
Yeah. So Wilderman19 asks, what was Jan's favorite project he built or designed?
This is difficult to answer. I think I like
it's something like which one of your children you love.
Exactly. That's exactly the same thing. I would also not be able to answer this question. Yeah, I don't know. I think I don't know. It's very, because in every project, not in every project, but at least in the project within all projects within the context of ICD and ITKE, I've seen every project kind of point that is pretty satisfying, I would say.
Yes.
Pretty like.
Yeah. Okay, we have another question. Louise asks, how do you balance creativity and sustainability in your projects?
I don't see if I don't know if I see a kind of contradiction between creativity and sustainability. I think sustainability requires creativity to achieve it. So I don't think, I'm sorry, I think I am not able to answer this question again.
Okay.
So I don't see a conflict between creativity and sustainability.
Okay, great. Okay. I don't see actually much. Questions are almost like the same, and I'm just skipping them. I will ask my own questions. How do you imagine the future of your own practice?
Yeah, so unfortunately, I'm not really a businessman, so I don't have a business plan for my practice. But I think I still, even after kind of 30 years of professional experience, I still think that this kind of satisfaction that you get when something that you worked on for 1 or 2 or 3 years is built, that is still kind of, that's still thrilling. It drives me, so it keeps me motivated. And I hope that you will be able to work on many exciting projects in the future.
In the future, yeah, that's great. That's great, awesome. As closer with all these experiences, teachings, projects, designs, what kind of advice would you like to share with young professionals and students, architects, engineers, all of them?
Yeah, I don't know. For me, it's kind of lifelong journey, I would say, or expedition of constantly seeking for new ideas, new concepts. I think stay cautious would be one advice. But what was also very important in my career is that I always had partners around me, people around me, environment around me, who somehow inspired me and was kind of basis for discussion and exchange of ideas. So I think one other advice would be look for an environment that supports you and provides a kind of creative context that pushes you, allows you to move forward.
Yeah, awesome. That's brilliant. Thank you so much. Thank you so much for this amazing discussion. I really appreciate that. We're going to end this discussion in 2 minutes. It's already 45 minutes. Do you have any final words to share with our audience?
No, it was a pleasure to talk to you.
Awesome.
I think I'm also I think we also are very happy that our projects receive so much of attention, also by you, Hamid.
Yeah, thank you so much.
That's something I really appreciate. I think it's very important for us that science does not happen in a kind of closed context, that it's kind of exposed to the world, but also kind of recognized by the world. That's very important for us, and we're very happy that, in particular, you are somehow promoting our project quite well. Thank you.
Thank you so much. We're just trying to expose the great work is being done by architects and designers all over the world, and we're sometimes finding some projects that are hidden in that part of the world, and we bring it to the spotlight to show them to the world, to designers, young generation, and everybody, to maybe to be a source of inspiration, source of knowledge for the next projects that they are working on, and that's what we are doing. And we're so excited for your upcoming projects as well.
Thank you very much, Hamid.
Thank you so much. Thank you so much for joining. Goodbye.
Bye-bye. Bye-bye.
Bye-bye. Guys, thank you so much for joining to this live session. This live session has just ended with Jan Knippers from Stuttgart, and we're looking forward to do more of these live sessions. Stay tuned with us. We're gonna share these live sessions and also this live session as podcast format on podcast platforms like Spotify, Google Podcast, and Apple Podcast. And also you can follow our page pa.sense to stay tuned with our podcast formats. This video will be published on IGTV and YouTube as well. So till then, stay safe and stay healthy. Goodbye.